Yes.
Yes,
Yes
po.
po.
Yes po.
Yes.
So, our topic for this day is about measures of dispersion or variability. So, dito class papasok ang range, standard deviation, variance, coefficient of variation. So, measures of dispersion or the measures of variability. When you hear the word dispersion, what comes to your mind? When the data disperse to each other, what does it mean? How the data spread out, right? Dispersion, disperse. How the data relate to each other, their distance to each other, something like that. That is measures of dispersion. You want to know the relationship of the data, okay, in each other. Are they equally distributed, or the data are dispersed? I mean, masyadong hiwa-hiwala yung data. Kasi merong data, like yung last time natin topic, yung merong mga data na tikit-tikit, tapos merong data, the outliers, yung nasa labas. Okay? Yung masyadong malaki, value. Tapos, meron namang the rest of the data, magkakalapit lang. How are we going to relate it? Like, for example, the salary in a certain company. The salary of regular employee, hindi yan ganun kalayo sa isa't isa, diba? Bawa, nagre-range yan sa, bawa lang to 15 to 18 for regular sa company. 15 to 18 monthly. Paano magkakaroon ng outliers? It depends on your position in certain company. Kung ang position mo ay regular lang, ay yung nasa mababa position, syempre, yung mga kalapit mo lang, yung mga level, yung salary mo. Pero if you are the owner of the company or you are the CEO, malayo yung agwat ng sahod. Okay? So, doon natin makikita we want to know how the data spread out. Okay? So, measures of dispersion class is a measure along the horizontal axis of the data distribution that describes the spread of the distribution from the center. So, this one and this one. So, itong figure na to, napakita na natin sa measures of center or for central tendency. Because for central tendency, that is the measure along the horizontal axis that divides the data into what or how the data distribution spread in the center. But now we want to know the spread of the data distribution. Okay? So dito naman yung mga data naman, dikit-dikit, magkakalapit sa isa't isa. Okay, measures of dispersion indicate the extent to which individual items in a series are scattered about an average. It is used to determine the extent of the scatter so that steps may be taken to control the existing variation. It is also used as a measure of reliability of the average value. So, kaya ang measure of variability commonly used in research. Kasi we want to know kung yung mga data ba, are they related to each other? Magkakalapit ba yung mga sagot respondents natin? That will test the reliability of the data of the instrument. Okay? So we use this to determine the extent of the scatter. So what steps may be taken to control the existing variation. Kaya sa research, karaniwan, kinukuha ang mean at standard deviation. Kasi gusto nating malaman o i-test yung reliability ng data. Kasi baka naman yung mga sagot nila magkakalayo. So the more na magkakalayo ang mga data, syempre hindi maganda. Sabi nga natin, the higher the value of the standard deviation, the lower the reliability. Kasi magkakalayo eh. Standard deviation is the average of the distance. Okay? Yung average distance ng bawat data. Kung masyadong malaki yun, sabihin magkakalayo sila. Kaya the lower the value of ST, the better. The higher, of course, hindi siya ganun kaganda ang data. Kaya doon pa lang sa SD, kaya ginagamit siya sa research. Maganda ba yung study mo? Okay ba yung result ng study mo? Kasi you want to measure the reliability of it. Okay? The relationship of each, their distance. Okay, so we have general classification of measures of dispersion. We have the measures of absolute dispersion. So dito papasok last ang range, standard deviation, and variance. And we have the measures of relative dispersion. Dito naman papasok ang coefficient of variation. And let's have first the measures of absolute dispersion. Are expressed in the units of the original observations. They cannot be used to compare variations of two datasets. Absolute dispersion, we are not using this to measure or to compare two things. Okay? But the other one, the other classification, we use that to compare variations of two datasets. But here, we will not use this to compare variations of two datasets. When the average of these data sets differ a lot in value, or when the observations differ in units of measurement. Okay, so for the range class, we just need two values, the highest and the lowest value. We want to get the difference of the highest and the lowest value. The range, or the R of a set of n measurements, is the difference between the largest and smallest measurements. We already compute for the range last time. So one of your activities, one of the items, activities nyo, we need to compute first for the range. Where in there, we get the difference between the largest and the smallest measurements. Example, a botanist records the number of petals on 5 flowers, and these are the number of petals. The 5, 12, 16, and 14. We're going to find the range. So you just determine the largest and the smallest. The largest is 14 and the lowest is 5. So the range is 14 minus 5. Answer is 9. Okay, quick and easy, but only uses 2 of the 5 measurements. So in finding the range, compute for the value of the range, you just need to determine in the given data the lowest and the highest data and get the difference. Next is the variance. So like in measures of central tendency, we have the population mean for mu, and we have the sample mean for the X bar. We also have for the variance. We have the population variance. We use later on the symbol for the population variance, and we also have the sample variance. Of course, for population variance, if you are using the entire population. For sample variance, if you are just using the sample. But then again, the formula, medyo magkakaiba lang ng formula. Okay, given this same problem, the records of the number of petals. So when we make a dot plots of this. This is the dot plots. You just need to make an upper line and plot the points. So we have 5, 5, 12, 6, 8, and 14. The variance class is measure of variability that uses all the measurements. It measures the average deviation of the measurements about their mean. So we want to know the relationship of the deviation. Okay, given the deviation or the average deviation related to the mean. So you need to compute for the mean. This is for sample. Okay, assume that this is, we're going to compute the sample mean. What is the sample mean given this data? Anyone? What is the sample mean? Because it says there that it measures the average deviation of the measurements about their mean. So later on, we compute the variance. But what is the mean first? Yes, Rob.
Ma'am, ano po? Mean is equal to 45 over 5 po. Then 45 divide 5, 9 po.
Right. The mean is 9. And here, the location of 9 is there. And then we want to know that is the variance. Okay, the distance of each point in our mean. Okay, the variance of a population of n. So since we're using population, we are going to use uppercase n. Measurements is the average of the square deviations of the measurements about their mean or the population mean. Since we're using population, we will have now population variance. Okay, and of course we have the population mean. And this is the formula. We're going to use this symbol. Okay, since variance is the square deviation of the measurements about their mu. Okay, so we have the summation of the squared of x sub I minus the mu all over n. But if we have the sample variance, the denominator becomes n minus 1. Yun lang yung pagkakaiba nila, class, yung denominator. And of course, instead of mu, we're going to use x bar. And we will have the symbol. This is the Greek letter. Ano nga bang Greek letter? Wait. Ito. The sigma. The sigma squared. So we have the sigma squared is equal to the summation of the squared of x sub I minus mu over n for the population variance. And for the variance of a sample or sample variance of n measurements, we're going to use lowercase n since we're talking about sample of n measurements is the sum of the squared divisions of the measurements about their mean divided by n minus 1. So instead of using population mean for the mu, we're going to use x bar for sample mean. And the denominator becomes n minus 1 if we have sample. Okay, for us to find the sample variance. We will discuss why the denominator changed later on. Okay, because later on we will see that if the denominator is n minus 1 for sample, it's nearer, the answer is nearer to the value of the variance. Okay, pag sample. Pero pag population, exact. Okay, mas malapit yung sagot nila. So later yan. So let's have first, let's have another which we have the standard deviation. Kung ang population variance, we're using the sigma squared for the standard deviation. Of course, standard deviation is the square root. That is the square root of the variance. So in calculating the variance, we squared all of the divisions, and in doing so, change the scale of the measurements. So since let me annotate. Variance is this is for population variance. Standard deviation is the square root of the population variance. So when we square root it, the symbol for population standard deviation is just a sigma. Population standard deviation. Okay, because SD is the square root of this. So when we square root this, we'll just have this symbol, the sigma. For sample variance, we have S squared. Okay, this is for sample variance. So when we square root this, the symbol for sample standard deviation is just an S. Sample standard deviation. Okay, next. To return this measure of variability to the original units of measure, we calculate the standard deviation, which is the positive square root of the variance. Okay, we will just include the positive square root or the principal root of the variance, and that is the standard deviation. Okay, so when we square root both sides, square root of the sigma squared, that is sigma, the square root of S squared, that is S. That is for sample standard deviation. Okay, so we have two formulas or two methods that we can use to compute for the sample variance. Once we compute the sample variance, we just need to get the square root of that to have the standard deviation. But if the given is SD or the standard deviation, you squared it. Okay, kasi dito, itong formula, this formula is to find the sample variance. Pero kung ang given class sample standard deviation, you just need to square it because sample SD is S. Para makuha ang sample variance, you square the answer. Okay, so this formula, to find the sample variance, we will have S squared is equal to the summation of the squared of x of I minus the mean or the sample mean all over n minus 1. So given the data, ito yung data natin class, yun sa you record the number of petals, 5, 12, 6, 8, and 12. Get the sum. So nakuha kanina ni Ralph, the sum is 45. Divide by 5, the mean is 9. Okay? Sorry. So the mean here is 45 divided by 5. So the sample mean is 9. Because in the formula, we have x of I minus the sample mean. So these are the x of I. 5 minus 9 is negative 4. And there is squared there. So squared of negative 4 is 16. 12 minus 9 is 3. 3 squared, that's 9. 6 minus 9 is negative 3. Squared of negative 3, it's 9. 8 minus 9 is negative 1. Squared of negative 1 is 1. 14 minus 9 is 5. 5 squared, that is 25. There's a symbol, summation. So we need to get the summation for this column. The square of x of I minus x bar. When we get the sum, that is equal to 60. So therefore, our numerator here is 60 over our n is 5 minus 1. So we will have 4. So therefore, the sample variance 60 divided by 4 is 15. So therefore, to find the sample SD, sample standard deviation, square root of 15. That is the positive square root of the variance, which is approximately, let's use your calculator, please use your calculator, square root of 15, that is approximately 3.87.
87.
Okay, if we round off into 2 decimal places, 3.87. This is the first way to compute for the sample variance. And after that, we compute for the sample ST. Clear? Are we clear?
Yes, ma'am.
Yes po.
Yes po.
Yes po.
Yes po.
I'm going to teach you how to use your cycle to compute for the mean and ST. So sa calcu class, ST ang makukuha, hindi ang variance. So therefore, dahil given ang ST, i-squared nyo na lang para makuha ang variance. Okay, so we have 3.87. Next, another formula to compute for the sample variance. So kayong bahala kung anong gusto nyong gamitin. Kung yung una or ito. Nasa inyo naman yan. Same lang naman ang answer. So for S squared is equal to the summation of x of I squared. So we need to square the data, each data, and get the summation of that. That is the summation of x of I squared minus the square root of x of the square root of the summation of x of I. So we get the summation of x of I and then squared it. So magkaiba to class. This one, we squared each data or each datum and then get the summation of that. Okay. This one, the square root of the summation of x of I, you get the summation, which is 45, and then you squared it. Okay, so magkaiba yan. Over n, all over n minus 1. Again, our denominator is n minus 1, kasi nga, iba sa population variance. Kasi sa population variance, ang denominator ay n lang. Okay, pero sa sample variance, it's n minus 1. Alright, so given again the data, we need to get the summation of this, which is 45, nakuha na yan kanina, and we squared each data. So 5 squared, that's 25, 12 squared, that's 144, 6 squared, that is 36, 8 squared, that's 64, 14 squared, that is 196, and get the summation of this. The summation is 465. Now we will substitute in the given formula the summation of x of I squared. The summation of x of I squared is 465 minus the squared of the summation of x of I. The summation of x of I, that is 45. Then square it. Over our n is 5. All over n is 5 minus 1. So simplify, what is S squared or the sample variance? Let's have F-ray. Use your calculator. Is it just the same sa unang sagot natin? The answer a while ago is 15. Ephraim, can you hear me?
Yes, ma'am.
So what is the answer?
15 po. Square root of 15
That is for
or
sample.
3
Sorry, I'm
square
going
root of
to
15.
3.887. So when we simplify this class, the answer is 15. Nakuha niyo ba? Do you have same answer?
Yes po.
Yes po.
Okay, so when we get the square root of 15, the answer is 3.87. So either of the two formulas, we still have the same answer. Okay, so it's up to you kung anong gusto nyo gamitin. Same lang yan na answer. But another way class is in your calculator. Kasi sa exam, may time limit yun to answer. So it's time consuming kung, how about kung madaming given, okay, measurements or observations. Ang haba ng process, di ba? Bago mo makuha ang summation, the summation of x of I squared, ganun din sa una kanina. Right? Kasi kunin mo ang mean, then x of I minus the mean, then you squared it, right? Then apply the formula. However, ito madali kasi we only have 5 observations, right? It's easy to find the sample variance. So about kung mahaba, halimbawa we have 10, 15, you can use your calculator to compute for the SD and for the mean also. Kung gagamitin nyo ay calcu. So sa calcu, if you have your cycle, I'm not familiar with the applications. Hindi ako nagamit ng applications or hindi ko lang siya ganun, hindi ko masyadong naaral ang functions sa cycle pag apps. Pero pag calcu talaga, sa calcu kasi, meron diyang symbol na stat. So this is my calcu. Kung ganito ang calcu nyo, canon. Pero yung isang calcu, yung laging ginagamit ng mga estudyante ay calcu yun. Casio, yung Casio. Kasi parang yun ang laging available sa lahat. Tsaka mas affordable. Pero diyang, pag canon ang calcu nyo class, kailangan mo mag-stat mode. Sa Casio, stat mode din. I-stat mode mo siya. Hindi rin ako familiar sa Casio kasi hindi ako nagka-Casio. Piliin nyo, i-stat mode nyo siya. Dito kasi sa Canon, shift, mode, and stat, number 3. At meron akong SD, number 1. And then, i-encode ko lang ang data. So, sa Casio, go to stat mode, lalabas dyan. Naka-stat mode na siya, i-encode nyo yung data. 5 n plus. Yun yung gamit ng n plus sa Casio. 5 n plus. Lalabas, n equals 1. Ibig sabihin, meron ka nang na-encode na isang data. Next, 12 and m plus again. Ibig sabihin, second data. 6 m plus, 8 m plus, 14 m plus. Pero yung iba, hindi m plus ang ginagamit. Equal sign lang. So, naka-stat mode na siya. Kasi karaniwan class ang calcu ay naka-comp. Pero kailangan yung i-stat mode. So, kapag naka-stat mode na, encode the data, 5, 12, 6, 8, 14. Try it on your calculator. And then, mode, apps, sa akin kasi apps, tapos may variance. Hanapin nyo sa calcu nyo, yung sa taas ng calcu, yung naka-orange, shift, tapos, yung stat, may nakasulat yatang stat sa taas. Medyo mahirap pag wala akong Casio. Kasi karaniwan Casio ata ang calcio ng iba eh. Pero kung Canon, apps, may S-bar dito na nakalagay mismo. Tapos, meron dyan, pwede yung computein ang mean, yung X-bar, that's the mean. Piliin nyo kung anong gusto nyo kunin. Yung may -1, that is ST. So, kung pipiliin ko yung number 4, sa number 4 ko kasi ay yun yung ST, yung may -1. Which is, sa calculus, lalabas, 3.87. 3.87. So, kung ang sa calculus ang ilalabas ay 3, ay ang ST, para makuha ko ang variance, kung ang tinatanong ay variance, i-squared ko lang to. Which is 15. I squared the answer. Hindi ako nag-round off. Kung ano yung lumabas, yung non-terminating decimal, I just squared it. The answer, I just squared it, which is equal to 15. That is the variance. Please try on your calculator now. Kasi, tawag dito, advantage yun. Advantage sa exam pag marunong kayong mag-manipulate ng calculators, lalo sa stat class. Okay, try on your calculator. If you can do it, you need to explore your calculator para alam niyo yung mga functions na meron dyan. Can you do it, class? Sa applications, pwede nyo din i-try, pero hindi kasi ako maalam masyado sa, kapag stats pag stat ang gagawin, pero pag ibang math naman, pwede naman madali sa akin. May mga simple calculations. Though sa application class, meron din namang stat mode. Kaso, hindi ko alam kung paano mag-encode dito. By the way, class, every time na meron kayong i-encode, okay, halimbawa, ito yung example number 1, you proceed to the next example, you always reset your calculus. Bakit? Kasi maging iba yung sagot. Dahil i-read niya pa din yung mga unang mong i-encode. Kaya always reset. Okay? Or clear all. Sa calculus, clear all, yung CLR, shift, then CLR. That's the use of that sa calculus. Para hindi niya na i-read yung mga naunang data. Okay? Do not forget to clear all or reset your calculus. Shift, CLR, then number 3 yung all dito. So, clear all. Then, equal sign. So, na-reset na. Okay? So, you need to explore your calculator. Anong mga functions na nandyan. Okay? Yan naman ay user-friendly naman. Naka-indicate naman kung ano yung mga pipindutin. Kung yung kulay, halimbawa, yung stat, kulay orange siya, ang gagamitin mo yung shift kasi yun yung kakulay niya, shift, tapos kung ano man yung function na gagamitin. Pero kung ang kulay niya ay kulay blue, alpha. Sa akin kasi blue eh. Alpha, tas yung function na kailangan mong gamitin. Nasundan ba? Nakuha ba using your calculator? The ST?
Ma'am, yes po.
How about the others? Math 1. How about the others?
Ma'am, yung ano po ba? Yung SD po sa calculator, yung ano,
Minus
yung
1.
number 4 po, yung may -1.
Yes po.
Okay po.
Pero class, hindi ko naman sinasabing gamitin nyo ang calcu. Kasi sabi ko nga, lagi ko sinasabi sa klase, especially sa math majors, huwag niyong hayaan na mas matalino ang calculator sa inyo. Okay? Dapat alam pa rin natin kung paano gawin to manually. Kasi hindi naman yan natin ituturo sa estudyante kung paano gumamit ng calcu. Kailangan natin ituro yung process. It's just that, mahalaga lang na alam nyo din kung paano gumamit ng calcu. Kasi what if your students ask you, ma'am, how I'm going to compute for the ST using my calculator? Or what if? You need to explore eh. Kasi hindi naman tayo, lalo ngayon, yung estudyante, dami nang alam sa mga applications, math apps. Meron pang graphing calculator. Hindi mo kailangan bumili ng graphing calculator. Mahal ang graphing calculator class. Meron ng mga applications din. Pwede din naman dito. Meron din, pwede nyong i-try kung gumagamit kayo ng laptop. Graphing calculator. Wait, share ko. Habang tinatry, ina-explore nyo yung calcu.
Okay, maingay.
Unmute. Unmute pala. Paki-mute. Kasi marami ng apps class, so dapat ini-explore nyo din yung sarili nyo na gumamit ng mga yon para pag tinanong kayo, alam nyo din kung paano gamitin. GeoGebra. Sa GeoGebra, may cycle siya, may graphing calculator. So let's use cycle. But then again, sabi ko nga, hindi kasi ako dito masyado pag-start. Kasi dito, madaming... Okay, let's try. I'm going to share my screen using this. Cycle. Sino ang walang cycle? Yung talagang cycle talaga. Raise your hand. Okay, wala. Okay pala naman, first year pa lang naman. Pero pag second year, mas okay kung meron na kayong cycle. Para first year pa lang, or second year pa lang, na-explore nyo na yung functions ng calculus. Okay, so dito sa cycle, sa GeoGebra, meron siyang hindi lang naman siya for, how dito? Hindi lang siya for graphing. Pwede din siyang for cycle. Okay, so dyan, i-encode nyo lang din. Kaso dito yata ay wala. Hindi ko, kasi tinry ko classic download ang Casio. Meron kasing app na ganun. Hindi ko alam ba't ayaw ma-download sa laptop ko. Pero tinry ko sa laptop ng kapatid ko. Kasi ganun ang ginagawa ng parang naano lang ako, na curious lang ako. Paano ba pag ipakita? Kasi hirap sabihin ko, ganito gawin nyo. Hindi nyo naman nakikita, di ba? Yun yung inaaral ko din. Anyway, so maraming applications na pwedeng yung i-share sa estudyante nyo or pag online pa din, pakita nyo. Sa graphing calculator, mas ginagamit ko ang GeoGebra. Doon kasi mas accurate yung graph. Lalo pag may mga curves, hindi naman kasi laging line. At mahirap talagang gumamit ng board, ng whiteboard, pag may mga graphs. So, I'm using GeoGebra para mas ma-appreciate ng mga estudyante. Anyway, so dito sa GeoGebra ng cycle niya, pwede naman din. Yan, may clear all din. Tapos, i-encode mo lang din kung gumagamit ka ng laptop, halimbawa sa pag-exam. Pero sabi ko nga, hindi ko alam paano dito ang stat. Pero sa cellphone, marami namang applications na pwedeng i-download. Alright. So, using your cycle, kung apps man or mismong cycle, nasundan kung paano gagawin. Kasi sa exam, gusto ko, at may time limit kasi, lalo pag nape-pressure na kayo, 2 hours lang kailangan matapos na to. May ibang part pa. Kung you know how to use your calculator properly, mas madali yung masasagutan. Okay, kindly explore your calculator. Alright, so let's continue. Some notes. The values of S is always positive. That is the positive square root of the variance. Yes, Garmay, do you have any questions, clarification? Okay, the value of sample standard deviation is always positive. And the larger the value of S squared or S, the larger the variability of the dataset. Like I've said earlier, the higher the value of the ST or the variance, the larger the variability. Sabihin, hindi maganda kasi masyadong malalayo yung distance nila sa mean. Diba? That is the variance. Masyadong malayo. So, dapat, mas okay kung yung magiging result nila, ng data, mas malalapit. The smaller the value, the better. Y divide by n minus 1. So, sa formula ng sample variance, the denominator is n minus 1. Bakit pa? Bakit kaya? Unlike sa population variance, it's over n. The denominator is just n. Because the sample standard deviation is often used to estimate the population standard deviation. Okay? Ginagamit ang sample standard deviation just to estimate the whole population or to estimate the population ST. And we know that hindi naman natin kayang, halimbawa yung study, hindi naman natin kayang gamitin na respondents ang buong Pilipinas. What if you just need to get some sample or part of the Philippines? Pili ka lang halimbawa, Cavite lang. Okay? Mas nakukuha, mas malapit yung sagot daw kapag ang denominator ay n minus 1. Mas malapit yung sagot ng sample ST sa population ST. Okay, dividing by n minus 1 gives us a better estimate of the sigma. Okay? Or the this is population standard deviation. That's why our denominator is n minus 1. Mas malapit yung sagot ng sample ST sa population ST. Alright, so that is for ungrouped data. Okay, so this is the formula. Like in measures of central tendency and measures of fractals, we have ungrouped and grouped data. Okay, so for approximating the standard deviation from a frequency distribution, this is the formula. Sample ST is equal to the square root of. So, ibig sabihin, ang sample variance, wala tong square root. Kasi the square root of the variance is ST. So, the squared of SD is variance. Okay? But if we are asked to find the sample ST, that is equal to the square root of n multiplied by the summation of f sub I x sub I squared from 1 up to k minus the square root of the summation of f sub I x sub I from 1 up to k all over n times n minus 1, where f sub I, that is the frequency of the I class, x sub I, we know that. So, ginawa na rin naman natin to sa central tendency at sa fractals. Meron tayong f sub I or f for the frequency. X sub I is the class mark of the I class, which is, when we say class mark, that is the midpoint of the lower and upper limit, or the average of the lower and upper limit. And x means, or the x bar, that is the mean of the frequency distribution, and n is the total number of observation. So I use x bar and lowercase n because the given is just a sum. Okay? So this is for group data. A while ago, yung mga formula kanina, class, that is for ungrouped data. So dito, we're going to use FDT again for the frequency distribution table. So let's try example. Same example. This is about the scores of 100 students in an achievement test. So as you've noticed, yung topic natin, magkakasunod-sunod sila, magkakadugtong. Okay? That's why I'm using the same problem. So x sub I is since given ang frequency natin, the f sub I, we need to get the x sub I, which is the midpoint. This is the class mark. How are we going to compute for the class mark? Class mark class is the average of the lower and upper limit. Okay, so let me annotate. So nakuha na rin natin itong class mark class last time. So 50 plus 54 divided by 2. So we'll have 52. Ito class ay nakuha na natin nung nakaraan. 57, 62, 67, 72, 77, 82, 87, 92, 97. Alright, so let's start with f sub I, x sub I. So you get the product of the frequency and the class mark. Let's have Jonathan.
$520 po.
520. Next, Arya.
171 po.
Okay, so we have 171. Let's have Rhea Lu.
496 po.
Next, let's have Aldrin.
871 po.
We have 871. Next, let's have Ronaldin Agustin.
1,224 po.
Okay, so we have 1,224. Next, let's have Nicole Andre.
1,463 po.
Right, so 1,463. Next, let's have Rachel Ann.
1,804 po.
1,804. Next, let's have Maylene.
1,131 po.
Right, 1,131. Next, let's have Jersey. Jersey, unmute.
368 po.
Okay. Next, and 1 times 97, that is 97. Okay. Okay, Joanna Marie, get the summation of f sub I, x sub I. The summation of f sub I, x sub I. Do you have your answer?
$8,145 po.
Correct. So we have 8,140. Okay, next. F sub I, x sub I squared. So it means that you squared first the value of the class mark and then multiply it by the frequency. Okay, so let's have Kyle. Dixon.
$27,040.
27,040. Next, let's have Emmanuel or Puko.
Ma'am, 9,747 po.
1,747. Next, let's have Andre Rias.
Wait lang po.
Oh, sure. Rias.
$30,752 po.
30,000.
42,752 po.
42,000.
30,752.
Okay, so let's double check. 62 squared times, 62 squared times 8. It's 30,000. Double check. Are you using cycle mismo or cellphone?
Ma'am.
Oh, so you double check. 62 squared. Then
Ma'am,
multiply
tama po.
8. 30,752. You need to be careful kasi isa lang mali dito sa table mo. Mali na ang sagot. Okay, next. Let's have Desit. Desit.
Mga 58,357 po.
58,357. Next, Hazel Ann Rivera.
88,128 po, ma'am.
88,128. Correct. Next, let's have Rhea Lu Inocilios. Unmute. Okay, so can you hear me? Or you have a problem with your audio? Let's have Christine Mary. Ramos.
112,651 po.
Okay, 112,651. Next, let's have Balila.
Ma'am, 147,928 po.
Okay, correct. Next, let's have Jenny Andal.
$98,397 po.
Next, Ramil.
33,856 po.
33,856. Correct. Next, let's have Julius Madraso. Julius,
3,856.
97 squared times 1.
Sa baba na pala. Lang, ma'am. 9,409.
Correct. 9,409. Okay, get the summation of f sub I x sub I squared. April Joy Mendez. Hindi kailangan magmadali class ha. Kasi pag nagmamadali, lalong nagkakamali. Okay, do you have your answer, April Joy Mendez? April Joy. Unmute. Please unmute.
Ma'am, sorry po, hindi ko po kasi maintindihan. Putol-putol po yung ano sa akin. Mahina po yung signal.
Okay,
Kanina
so
pa po ako hindi
get
ano po.
the summation of this. Did you try? Okay, so let's call other students. How about Gemma?
Ma'am, solve ko lang po.
Yes po.
$616,265 po. Hundreds ko pala. 600. Tama po.
616,265. Do you have the same answer, class, for the summation?
Yes po.
Yes po.
Ma'am, yes po.
Yes po.
Okay, so let's compute now for the sample ST. Space. So again, the formula for the sample ST, that is equal to the square root of so I'm going to use formula. So we have the formula S is equal to the square root of N times the summation of F sub I, X sub I squared. Di ko na sulat yung I from 1 up to K minus the summation of F sub I, X sub I squared over N times N minus 1. In the given, the summation of F sub I, X sub I squared is, what is our answer? 8,145. Diba? What is our answer? What is the summation of F sub I, X sub I squared?
616,265.
65 po.
Wait, that pala. Again. Wait. Open ko lang. Wait lang, class ah. Okay, you try to compute for the S. For the sample ST. What is again the summation of F sub I, X sub I squared?
616,265 po.
For F sub I, X sub I squared. And then for the summation of F sub I, X sub I, 8,145. Mababa class.
Opo,
Opo,
ma'am.
ma'am.
And our
Opo, ma'am.
N, we know that we have 110 students. So square root of for and then multiply by the summation of X sub I squared. That is 616,265 minus the square root of the summation of F sub I, X sub I, that is 8,145. Over, we have 110 times 110 minus 1. Okay, what is the sample ST? What is your answer? Let's have Aldrin Sanz. So your answer should be a positive square root.
Wait lang po, ma'am.
Push. I'm using the symbol for approximate value since it's positive square root, hindi naman siya laging terminating or exact. Can be non-terminating. Do you have your answer?
Yes po.
Yes po.
Ulit yung tinawag ko kanina. Si Sans. Alvin Sans. Do you have
Ano
your
po, ma'am?
answer?
10.98 po.
Or round off? 10.99. When
Opo.
we round off, that is 11. Ito whole. Okay, that is our ST. So, ni-round off into whole number ko na class. But, if you want, into decimal places, 10.99, kasi siya 10.98989. So, when we round off, malapit na siya sa 11. So, round off my answer into whole number. That is the sample ST. Okay. How about the others? Do you have the same answer?
Yes, ma'am.
Ma'am, yes po.
Yes po,
Opo.
ma'am.
Okay, good.
Yes, ma'am.
So we'll not discuss this empirical rule. Okay, so we'll proceed now to measures of relative dispersion. Our unit lesson are used when one wishes to compare the scatter of one distribution with another distribution. Now, the first one, we cannot use that to compare the two variations or two different sets. But this time, for measures of relative dispersion, we are going to use this if we wish to compare two data. Okay, to compare the scatter of one distribution with another distribution. So we have the first one, we have the coefficient of variation, which is the ratio of the standard deviation to the mean and is usually expressed in percentage. It is computed as CB is equal to the population variance as the population SD over the population mean times 100%. So you're going to use this if you are using the entire population. But if you are using the sample, you will have S over the X bar times 100%. So your answer should be expressed in percentage. Okay, so it's just the same. It's just that the first one, this is for population, and here this is for the sample. Next. Okay, so let's try this example. Kindly read the problem. Let's have Jewel, Kyla.
Elaborate.
Wait lang, sorry.
Laboratory.
A laboratory technician studied recent measurements made with two different instruments. The first measured the diameter of a ball bearing and obtained a mean of 4.96 millimeter with standard deviation of 0.022 millimeter. The second measured the diameter of a metal rod and obtained a mean of 6.48 millimeter with the standard deviation of 0.032. Which of the two instruments was relatively more precise?
Okay. So here for the coefficient of variation, the lower the value of the answer, the more precise. Okay, so the more no mas mababa daw. Kasi nga yung distance nila mas malalapit. Okay, so we'll compute for the CV for instrument 1 and for the instrument 2, and then we're going to compare the answer. So for the CV1, for the first instrument, it says there that the first measured the diameter of a ball bearing and obtain a mean. The mean for instrument 1 class is, let's use the first measured the diameter of a ball bearing and obtain a mean of 4.96. With standard deviation standard deviation 0.0. For the second instrument, the second measured the diameter of a metal rod and obtain a mean of 6.48 millimeters. This is for the second, sorry. This is for the second instrument. 6.48 millimeters. And for the standard deviation, for the second instrument, we have 0.032 millimeters. Okay, yung problem class nasa PowerPoint. So, kinuha lang natin yung mga given. Okay? So, let's compute for the coefficient variation for the first instrument. So, we will have the population ST over the population mean times 100%. So, kindly compute in your calculator. Ito na lang. 0.022 millimeters divided by 4.96 millimeters times 100%. So we can cancel the unit. What is the answer? Then multiply it by 100. 0.22. 0.22. What is the answer? Yes, April Joy.
0.44 po.
Yes, the answer is 0.44%. Do not forget. The coefficient variation of the first instrument is 0.44%. And for the second one, the coefficient variation of the second instrument. So, population ST divided by the, population ST over the mu times 100%. So we will just substitute 0.032 millimeters divide by 6.48 millimeters times 100%. So what is the coefficient of variation of the second instrument? Yes, Mylene.
0.49% po.
Alright, so we have 0.49%. So the question is, which of the two instruments was relatively precise? We need to choose. So like I've told you, the lower the better. The lower the value, the better. The lower the value of the coefficient of variation, the better. Yes, Ralph.
Ma'am, yung nauna po yung experiment 1.
So we have, that is instrument. Instrument number
Ay, sorry.
1 was relatively precise. Right? Is that clear, class?
Yes po, ma'am.
Yes po.
Okay, so let's continue. Last na yung next topic. Hindi natin tatapusin yung buong nasa PowerPoint class kasi masyadong mahaba yun. Yung mga basic lang. Measures of relative standing. Yung mga pwedeng magamit sa klase. When you are going to interpret the result of the pieces, you want to interpret yung result ng section A sa section B, something like that, or yung performance nyo sa English, sa math. So that, dito naman yun papasok. Kasi we are comparing two data sets, right? So measures of relative standing, okay, where does one particular measurement stand in relation to the other measurements in the data set? How many standard deviations away from the mean does the measurement lie? Okay, this is measured by the C-score. C-score, that is X minus X bar over S. Or, this is for sample again, if you are using the sample. If you are using the population, that is C equals X. Of course, we're going to use the mean over the sigma or the population ST. Then it says there that how many standard deviations away from the mean does the measurement lie? The given, we have the X bar. The X bar is 5. That's the mean, and we have the given data 9. Okay, you want to know ilan ba ilang SD ang meron from the mean to one of the data. So we have 4. We're using the C-score. Okay. Suppose S equals 2. So if we're going to use the formula for C-score, where S is 2, okay, 9 minus 5, it's 4. Divide by 2, that's the value of S, which is 2. C is 2, right? Again, 9 minus 5, it's 4. Divide by 2, we have 2. C equals 2. And we know that, siguro naman na-introduce na din sa inyo yung Z-table. Yung value ng 2 sa Z-table, nandun yun. So, the higher the value of the C-score, the better, di ba? Mas mataas yung value. Yun ay decimal number. 4 decimal places. So, pag mas malaki yung number, mas malapit sa 100%, di ba? Pag negative, going to the left, yung value ng Z, mas lumiliit. So, pero, yan hindi na natin masyado interpret. So, therefore, here we have 2 standard deviations from the mean. Since ang z-score natin ay 2. And then, the standard score measures how many standard deviation and observation is above or below the mean. It is computed as, so ito na, introduce ko na, z-score is equal to x minus x bar over s. This is for sample. And for the population, we have z equals x minus mean over the population ST. So let's try this example. Please read the problem. In this example class, we want to compare kung saan ba mas nagpe-perform ng mas maayos si Ruel. Is it in English or in history? Let's have Balila. Kindly read the problem first, then we will answer it.
Ruel got a grade of 75% in English and a grade perform better.
Akin lang ba may problem? Okay, again, Ruel got a grade of 75% in English and a grade of 90% in history. The mean grade in English is 65% and the standard deviation is 10%. Whereas in history, the mean grade is 80% and the standard deviation is 20%. Class, please be reminded na laging magkasama ang mu at ang ST. Okay? At itong Ruel got a grade of 75%, ibig sabihin, yun yung grade niya doon. And this will be the population or the sample ST. This is the population mean, and this will be one of the grades, yung X, yung the value of X. Kasi the formula, parang ang gulo ng explanation. Again, the formula of Z is equal to X minus X bar over S, or X minus mu over the standard deviation. So, laging magkasama sa problem, si mu, kasi sabi the mean grade, and an ST. Itong X bar, that is one of the data, right? Yun yung specific yung grade na ni Ruel. Alright? So, Ruel got a grade of 75% in English and a grade of 90% in history. So, we will compute the z-score in English and the z-score of history. At this time, kung sa coefficient of variation, the lower the value of the coefficient of variation, the better. It's more precise. Here, for z-score, kasi yung value sa z-score class using the z-table, the higher the value of the z, it's more nearer to 100%. Okay, so the better. Sabihin, the higher the value of the z-score, the better. Alright, so Ruel got a grade of 75% in English and a grade of 90% in history. The mean grade in English is 65% and the standard deviation is 10%. Whereas in history, the mean grade is 80% and the standard deviation is 20%. In which subject did Ruel perform better? So let's try to answer the problem. So let's summarize. Again, in the given, sa English class, this is for English. Ang grade ni Ruel ay 75%. And then, sa history, ang grade niya ay 90%. And then, the mean grade sa English ay the mean grade in English is 65%. Then the SD is 10%. In history, the mean grade is 80%. At ang SD ay 20%. Kaya class laging kinukuha ang mean at saka SD eh. Ginagamit din sa research. Kasi 'di ba, mas naaapektuhan ang mean kaysa sa median. Okay? Ng overall. Sa overall, mas naaapektuhan ng mean kaysa kay median. Kasi yun din ang ginagamit dito sa pag-compute sa z-score. So, let's compute x minus mu. This is for English. Z for English. X minus mu over the standard deviation. X is 75 minus the mean. So, ang performance nyo nakadepende pa din sa performance ng buong klase. Hindi pwedeng i-compare mo lang yung performance sa nakukuha mong grade. Kailangan mo pa rin yung result ng buong class. Okay. 10%. So, hindi ko na sinulat class ang 10%. Yung percent symbol. 75 minus 65, that's 10. Divide by 10. So, the z-score is 1 in English. At meron tong meaning sa z-table. So, hindi ko na ang kailangan lang naman natin, we just need to compare the value. So, sino mas mataas, dun siya mas better na nag-perform. And for the z-score in history, we have x minus 2 over standard deviation. So, for history, we have 90 minus 80% over, lahat naman kasi sila class in percent eh. So, hindi ko na sinulat. 20. So, 90 minus 80, that's 10. Divide by 20, or 1/2. That is 0.5. Okay, so the question is, in which subject did Ruel perform better? Let's have Rina Rosales. In which subject did
Ma'am,
Ruel
English
perform
po.
better? Okay, so Ruel,
English.
very good. Ruel performed better in English. Right, so that is the answer. Tingnan nyo class, the more na mas malaki kasi yung value ng SD, syempre may effect yun sa z-score. Mas lumiliit ang value. Dito ang SD natin, 20. Sa English, 10. Okay? Pero kung titingnan nyo, ang grade niya, mas mataas talaga sa history. Okay? Kaso, dahil sa yung agwat ng mga scores or grade sa klase, malalaki. You get yung point ko. Overall, mas okay pa din doon sa English kasi mas maliliit, mas malalapit yung score or yung grade nila sa klase. Kahit ang grade niya ay 75%. Okay, so hindi ibig sabihin na mas mataas ang grade mo sa English kaysa sa history. Mas nagpe-perform ka na doon ng mas maayos sa history dahil mas mataas eh. Hindi yun ganun class. May effect ang population mean at ang SD. Okay, are we clear with this problem? Do you have question about the standard score, the relative standing? Do you have questions?
Wala. Wala po.
Wala
Ganun
po.
Okay, so that is the end of our discussion. So if you don't have any questions, before you leave, kindly comment your name for your attendance today. I'm going to send a copy of the screenshots ng exam. Okay, so that's all for this day, Math 1. Goodbye, class.
Goodbye po. Thank you po.
Thank you po.
Bye po, ma'am. Thank you.
Goodbye po. Thank you po.
Thank you po.
Have your lunch now.
Thank you
Ma'am.
po, ma'am.
Yes.
Thank you po.
Thank you po.
Do you have question? Sino yung nag-ma'am?
May recommended po kayo na calculator.
Ayoko kasi sabihin, pinopromote ko. Pero I'm using Khan.
Okay po.
Tingnan nyo na lang yung list sa board exam. Kaso hindi kasi updated yung sa PRC. Yung list nila, hindi yun updated. Kasi merong mga calculus na hindi pwedeng gamitin sa board exam. Kasi yung iba nga, meron pa last. Pero sa engineering yun, merong mga calculus pinagbawal na kasi nag-program sila. Tingnan nyo na lang. Pero itong calculus na to, sabi dun sa binilan ko sa national ay naman daw, kasama naman daw sa list. I'm using Canon. Canon F789 SGA.
Okay po, ma'am. Thank you po.